All right, so our review with linear equations begins with those three equations for us. Okay, we need to be able to find slope. We need to be able to write equations in slope-intercept form. And sometimes we will start in point-slope form in order to get there. So if I gave you something like example 1, you are going to find the equation of the line between those 2 points. Where do we start? Slope. I'll warn you, this one doesn't turn out super nice. That's okay, though. Remember with slope that it doesn't matter which point is your x1, y1, and which one's your x2, y2. It just matters that if I start with the -2 on the top and do -2 minus 8, I have to start with the 4 on the bottom. I can't reverse the 4 and the -3. Okay, or you can do the opposite way. Minus a negative turns into a plus. But either way, you're going to end up with the same slope. Once you get your slope, this is where we use which version? Point slope. Does it matter which point you use?
No.
No. Do we have an emotional attachment to either point?
Yes.
Which one?
The first one.
The first one? All right. So if we use the first point, I would do y minus y1 equals my slope times x minus x1, which is going to turn into plus 3. If I would like my equation to end in y equals form, what must I do first? Distribute. You are right. Distribute first. All right, so a little fraction practice here. When I distribute 10/7 to 3, what do I get? 30 over 7. Good. Now, when I need to add the 8 to the other side, what do I need to get to be able to add it? Common denominator. Okay? Which I don't know why I just did that. All right, common denominator for 8 would be 56/7. Right? 8 in terms of sevenths. 8 times 7 is what? 56. Yeah? So I changed 8 into terms of sevenths, which is 56/7. Lovely numbers here. So my final answer, what's going to be my y-intercept? 26 over 7. Okay? Now, that's probably as gross as they get, and we just kind of started there. But be able to find a slope, be able to plug it into point slope form, and solve for y. That's kind of the main goal of the first set of notes here. Okay? Another thing is being able to solve for y and make sure you get your equations into y equals mx plus b form. So if I look at something like example 2, what's the only thing I can do to simplify an a? Distribution. Now, the one thing I want to caution you on, because some of you were doing it on your test or your quiz, you distribute here. Okay, this is not exactly y equals mx plus b form, right? Because the x is not first. When I reverse the order here, you take the signs with them. Okay? Some of you were not doing that on your tests or quizzes when you reverse things. So when I take the 10x and I move it in front, the 10x remains negative and the 15 remains positive. Once it's in the right form, then you can tell me what is the slope and what is the y-intercept. So if I was to graph this, I would start at a y-intercept of 15. And I would use a slope of -10. Take a minute on your own papers and solve B for y. We can solve for y. We can write equations of lines. I'm going to go ahead and skip example 3 because I do not like standard form. There's really no point. Oh, no. Spilling things. But we are going to talk parallel and perpendicular lines. All right. When we hear parallel lines, that means what? No one's listening.
Sorry.
Never intersect, same slope. Same slope is what we were going for.
Oh, well.
Parallel lines, we're skipping example 3. Cross it out. All right, now we're back on the same page. I can tell I'm not going to be able to let you guys do anything on your own today. Parallel lines, same slope. Perpendicular lines, negative, opposite reciprocal.
Opposite sign.
Reciprocal. Yeah, that's the word. There you go. Negative reciprocal slope. Good. All right. So recalling how to write parallel and perpendicular line equations, we use point slope for that as well. So on the next page, if I have the equation y equals 3x plus 1 and the point 3 negative 2, we would like to write an equation that is parallel. We would also like to write an equation that is perpendicular. We're going to do two at once here. All right, so let's handle parallel first. Parallel means same slope. So looking at that, what slope am I using? 3. I don't care about anything else in that line. I just care about the 3. Then I have the point, 3 negative 2. So where do I go from here? Point slope. Y minus y1 is going to turn into plus 2 equals 3 times x minus 3. So then what do? Distribute and solve. What is going to be the only difference between that one and perpendicular? The slope. What slope am I going to use for perpendicular? The negative reciprocal, which in this case becomes what? Negative. Yeah.
1 over 3.
Okay, so now you solve both. All right, check your solving answers there before we move on. Check your solving answers. Any issues with solving for y, parallel, perpendicular? We're all good? All right, let's look at example 5. If I would like to show that a triangle with those vertices, the corners, is not a right triangle. This initially looks like it has nothing to do with what we're doing. But what did we just talk about that makes right angles? Perpendicular lines. So, what could I do to show that this is not a right triangle in example 6? There's options. Okay? You don't even have to replace with perpendicular, you just have to find slopes. If I said I've got these 3 points, and you don't have to graph this, but like visually speaking, here's A, here's B, C is 7, 7. That would be like out here. Okay? This would be what my triangle would look like. My triangle's made up of 3 lines. I have the line from A to B, I have the line from B to C, and I have the line from A to C, right? So I could just find all 3 slopes, right? If any of my slopes were negative reciprocals, it would mean I had what kind of angle? A 90-degree angle. If none of them are negative reciprocals, then I don't have that, right? So we would find the slope from A to B. We would find the slope from B to C. And we would find the slope from A to C. If I find all 3 of them, and none of them are negative reciprocals, then it's not a right triangle. Okay? So, setting up the slope from A to B, you can either subtract A minus B or B minus A. It really doesn't matter. What slope do I get for that? What do we get when 0's on top? 0's on top is 0. 0 on bottom is undefined. Okay? It's worth talking about because we always get those mixed up. The slope from B to C would look like this. And the slope from A to C would be 1. None of those are negative reciprocals. In fact, they are all either positive or 0, so you're really not getting negative reciprocals. So it's obviously not a right triangle. Example 6 asks us to find the solution of 2 equations of lines by graphing. So let's review graphing. If I drew myself a little sketch here, how would I draw, or how would I start drawing the line f of x equals 2x minus 1? Where would I start? Okay. I would start at negative 1. I would then count up 2 over 1, up 2 over 1, and so on. That really does not look like a straight line, but that's okay. My drawings are not that good. What about the other line? Doesn't really look like a line right now, does it? No. What do I do to that before I graph it? Well, that's going to give you a 3 on the other side. So you don't really want to do that. What you do want to do is turn it into 2 fractions here and just divide each part. So if I divide 3 into 15, I get what? 5. And if I divide 3 into 2, it doesn't divide, but that still leaves me my slope, right? So where would I start that line? Up 5. All right, I need to extend my graph here a little bit. Up 5. And then it goes down 2 over 3. Okay, now on this one, this isn't a great example for solve by graphing by hand, because do they intersect in a nice place? No, they don't. So on something like that, wherever that is 2 point something, I don't know, 3 point something. I'm just taking a guess at that. If you were actually asked to do that, okay, we could graph the lines ourselves. We could do a lot of different things to actually solve that. Does anyone know how you could solve this and get an actual answer for x? You could use your calculator. What could you do in your calculator? Graph your lines and ask your calculator to find the intersection. Also, when you graph 2 lines together, we have referred to that in the past as a system of equations, right? What are other ways to solve systems of equations? Substitution, elimination. So like if you didn't have a calculator, I could set this equal to the other one and solve for x. I'm not going to make us do it right now, but I'm just kind of leading us through problem solving ideas if you had to. But if you had a calculator and you were asked to graph and solve, you could graph and find the intersection, and that would work just fine. Okay? We're going to spend time on systems. I'm just bringing us ideas. All right? Yes, ma'am?
Sorry.
Later unit. Yep. Nothing? You're stretching?
I'll ask after this.
Okay. That's fine. All right, so I'm going to have you work on example 7 on your own after we just talk about the initial setup, and then we'll talk word problems and be done. Okay?
Can we be on the whiteboards?
Oh, do what on the whiteboards? On this? This problem?
No, I think we do whiteboards.
I don't know if you want to right now. I think you want to be done. All right, on example 7. The setup's a little bit different. What are we being given in 7? Yeah, what is the f of negative 2? Okay, that's your x. Which means what's the 6? Your y. So this is a point. Negative 2, 6. What's my second point?
1, negative 3.
All right, do we know how to write an equation of a line given 2 points? Yes. All right, take a minute and practice that, and then we will finish with word problems. So once we checked 7, going through the homework while we're at this so you can follow along with this, we're not going to do questions 1 and 2. We will start at 3 and go through the rest. So you, not on the examples, I mean on the homework. So, okay, yes, but the word problems are quite a bit less. So just what we're focusing on is can we solve for equations of lines for the basic stuff? That's where it's easy. We'll cut stuff back on the word problems, okay? All right, so here on the homework for 3.1, we are cutting out 1 and 2, and we are doing from 3 through the bottom, which I think is like 10 problems maybe, okay? The one thing I do want to edit here is that it says to write it in that form. No, we are going to go y equals mx plus b on those forms, okay? Are we clear on the 3.1 stuff before we talk about word problems? Okay. Yep. All right, so word problems here. We are going to take the 3.2 stuff in 2 parts. Okay? No. All right, folks, focus with me. Shh. All right, so when we talk word problems with these, we are not going to be doing all of 3.2 today. We're starting 3.2 today. We are finishing it next class. And it's not that like we're doing parts of all examples. It's in my mind, it works, okay? So here's my goal for today with the word problems. The word problems come in basically one of two forms. And I want you to be able to recognize them and pull information out. I'm less concerned right now with being able to solve for the equation of the line. So today with the word problems, we're talking setup. Next class, we will talk solving for the equation because we already know how to do that, but also like answering the question asked. So that's kind of why we're cutting it into two parts. Now, just like when we did equations of lines on the stuff that we just did previously, we wrote equations of lines in two different ways. If you are given 2 points, then you found slope, went to point slope form, and on. Or you were given a slope, either parallel, perpendicular, you're given the actual slope and a point. You did point slope, and you moved on. Okay, so that's going to be how word problems work too. All right, so if we read example 1. Reading example 1. Or this is going to take 15 million years, which I don't want it to. All right, so in example 1, we are told a doctor purchased a new car in 2001 for $32,000. In 2004, he sold it to a friend for $26,000. We would like to write the equation of a line for this, okay? I'm going to work this one the whole way through just to show you a few things. But when you read these word problems for these, you need to think either am I being given 2 points or am I being given a slope and a point? It's one of two things every time. Any guesses as to which one this one is?
2 points.
2 points. Why do you say 2 points?
Because there's 2.
Right, so if I'm looking at it, the first thing you see in 2001, it was this much. Second thing, in 2004, it was this much. So they're saying, here's an X, here's a Y. Here's an X, here's a Y. So really, one thing I want you to practice setting up for this is what your X and Y's represent. So the first thing I am going to write down on each one of these is what is representing my X and what is representing my Y. One thing that you will see that you might not see right this moment, but I'm going to tell you, is that if there is 2 things and one of them is time, time is always the X. So if time is my X, what is my Y?
Anything else?
Anything else. In this case, it's what? Money, price. Okay? So I want you to practice writing that down because sometimes you could flip it. And if you flip it, what does that make your equation? Completely different than mine, right? So if you don't tell me what's your X and what's your Y, I have a hard time following you. Sometimes, like we're going to talk about in the notes and the homework here, they kind of give you an idea which one should be which. This one it didn't, but we're going to learn time goes first typically. So if time is my X and price is my Y, what's one point that I could write down?
2001.
Okay, that's 1 point. Second point.
2004, 26,000.
And once you get that information out of there, then you're just writing the equation of a line like normal, right? Find your slope, go to point slope form. Now the one thing I'm going to show you is this in a minute. If I set up my slope, I got 26,000 minus 32,000 over 2004 minus 2001. Lovely numbers. I get negative 6,000 over how many years? 3, which gives me a slope of what? Negative 2,000. Does it make sense that the slope would be negative in this case?
Yes.
Yeah, because the price is going down, right? All right, so then I'd go to point slope form. And like we did with the other ones, we can pick a point. Does it matter which point? First one, okay? So now here's where I'm going to show you something. When you plug in either one of the points, okay, bless you. All right, from right here, where would I typically go? And I just heard, oh, because these are big numbers, right? Okay, because of how we set this up. Okay, remember to think about like y-intercepts are 0, something. If I solved this out, it's going to have the slope of negative 2,000, and then the y-intercept is going to represent the price of the car in the year 0 BC. Because of how we've set this up. Because we are saying 2001 and 2004 are our X's. is it realistic that the y-intercept of this would be 0 BC? That really doesn't make sense to track the value of a car that far back. In reality, what would be a better y-intercept for us? Really, this would be the better y-intercept. Because that's when the car was new. But when the car was brand new, the first time it was sold, that was its price, right? So if I want to make this a little bit better for me, a good thing to remember is that instead of making it 2001, you can say, all right, that's my 0. If that is my 0, what does that change 2004 to?
4.
Not 4.
24.
Okay. 0 is the year 2001.
3.
So 2004 is 3.
Do we change that after we've solved for the slope?
I would like us to begin setting them up that way at the beginning. But the first time we do it, it wouldn't make sense for me to say, hey, let's just make 2001 0. Like, I wanted you to see why. So we went through it that way so that you could see why. Now, what that really does for me, it changes nothing in my slope. Because 3 minus 0 is still 3, right? What does it change in my point slope form? The 2001 changes to 0. And in fact, would I have had to do point slope form at all?
No.
No, because the slope would be negative 2,000, and what would be my y-intercept? 32,000. So I could have gone right to this. Okay? So I could have distributed and solved if I wanted to, but if I recognize that the year it was bought initially is my time 0, it actually helps me out. Now, some of these questions will be worded in such a way that it says, write the equation as a function of the number of years since 2001. And when they say that, that's what they're saying. Start at 2001. That's your 0. That's your y-intercept, and go from there. It makes a lot more sense to do that than all the years out. Okay? If this one says to interpret the slope, it's asking you, what does it mean in real life context? So what does this slope of negative 2,000 mean for real? What's happening?
Every year.
Okay, so every year, what? What is decreasing?
Car price.
The car price decreases by $2,000. So when it says interpret something, that's what it means. Write me a little statement about what does this mean in real life. Okay? Now, I spent a lot of time on the first one. What we're going to do in the rest of the examples throughout here is not so much write the whole equation. I want you to practice reading it and pulling out either 2 points or a slope and a point. Okay? So let's look at example 2 together, and then we will do the same process throughout. Okay? So this one tells me a new math program at a university has grown in enrollment by 14 students per year for the last 5 years. If the program enrolled 50 students in its 3rd year, what is the equation for the number of students in the program as a function of the number of years since its inception? All right, so lots of words, lots of things to interpret. First thing I want you to do on every single one of these, set up what your x and y represents. So what are the 2 things we're talking about in this problem? Students and years. Which one should go where? Okay. Years is my x. So number of students is my y. All right, so given that setup, do we see any information we can pull out from this? A point, a slope, 2 points, any of it? Trey?
A slope is 14.
Mm-hmm.
And in the 3rd year was 50, so that means basically T of 2 would be 50.
Mm-hmm. All right, so slowing down just a minute here. He says slope is 14 students per year. So what I want you to start recognizing is this word right here. Okay? Notice how that phrase, 14 students per year, represents both variables at once. Okay, it has the students and it has the years. So how I could technically write that is 14 students in 1 year. Now, why I write it that way is because I want you to think in terms of slope. Slope, the top of it is subtracting the y's, the bottom of it is subtracting the x's. That's what I'm seeing here when they write it as students per year. Students on top is the y's, years on bottom is the x's. That's my slope. Okay? So I'm going to set up. Slope is 14. Is it a positive 14 or is it a negative 14? Positive. Why? What word? Grows. It's getting bigger. Secondly, it tells us the program enrolled 50 students in its 3rd year. All right, so this setup up here is helping me. 3rd year is 3. 50 students is your Y. Now, in class yesterday, they asked me about this right here. For the last 5 years. Sometimes they're going to put in pieces of information like that that are less necessary. What they are saying in that statement is that for a certain time period, this looks like a line. After that, we're not real sure. So we don't know if it's going to continue being that way. We just know in this section of time, these 5 years, it makes a line. Okay? Would you know where to go from here to write the equation? Point slope form, right? Y minus y1 equals m times x minus x1. But I'm not going there right now. Like I said, I want you to read the questions, pull out information. So take a minute on your own. Read example 3. Decide whether you're getting 2 points or slope and a point. All right, so if we set degrees Fahrenheit as our x, degrees Celsius as our y, what are we given in this one?
2 points.
2 points. So we have 41 degrees Fahrenheit as our first point with what? 5 degrees Celsius. I technically don't have to write these degrees in here, yeah? I don't know why I am. Which means our second point would be what? 25. And then you'd find your slope, go to point slope form, write me an equation.
Yeah.
Easy?
Yes.
All right, we're skipping example 4, cross it out, go to 5. Okay? We're not solving any of these. I'm just setting them up. Settle. Whine, whine, whine. Don't tell me this is that hard. No, okay. We're almost done, Jackson, for your birthday. Well, I don't sing. So, there we go. All right. Let's finish these and then we'll be done. All right, so in 5, the demand per week for a 26-inch television set is 1,200 units when the price is $5.75 each. 800 units when the price is $7.25 each. Find the demand equation for the sets, assuming it's linear. All right, so remember how we said we set up an X and a Y first for every single one? What are the 2 things we're talking about here?
Units and dollars.
Units and dollars. Okay, so when we've had all of the other ones, one of them's been time. So we knew what to put for the X. This one, it's kind of questionable, except for the last sentence. And it's something you won't recognize, but I want to show you to recognize. It says, find the demand equation. They are telling me that that is my Y. The units demanded is my Y. That's what they're telling me. Okay? So what does that automatically make my X? The price. So I'm going to set up price with units demanded, or the units in demand, or whatever you want to put there. That's my X and my Y. So given that, what are they giving me here? 2 points or a slope and a point? 2 points. What's my first point? 575, 1,200. Second point? 800. Yep. All right, so I want you to start recognizing when it says something per something. They are telling me 2.3 inches in 1 year, and they're relating the 2 variables together. Okay? I also want you to start noticing, if you don't know which one is your X and which one is your Y, which one goes on top and slope? What variable is on top and slope? Y, right? It's Y2 minus Y1. They're telling you this is your Y and this is your X. So if they give you the slope, the way they word it tells you that. Okay? All right, also, I told you that last sentence will often tell you that. So if I read through that, it says, find a function that describes the height. The height, therefore, is the y. Okay? So there's several places they're telling you which one's the x and which one's the y. It's just learning to recognize them. So one thing I will write down is my age is my x and my height is my y, or inches is your y, whichever one you want to put. So we already said, what's my slope here? Okay, is it positive or negative? Positive, because children grow, right? We hope. Second piece of information they're giving me is what? Okay, age of 8 and height of 50.6. This is where I like to set this up first because the wording in it is not always giving you the x first and the y second. So knowing which one's the x and which one's the y, now I can say at age 8, the height is 50.6. Then you'd go where? Point slope form. All right? Last example I want you to read and set up on your own is 7. Give me what your x and y are representing and give me the information you can find. Remember that last sentence here? Find a function that describes what? The value. That is your y. Also, they tell you after x years. They're telling you time is x. Read it closely. Therefore, I would set up time as my x, value or price as my y. Are they giving me 2 points or a slope and a point? 2 points. First point, 3 years, 360. Second point, 7 years, 640. We all okay with those? Yes. All right, so let's talk homework on this. Just like what we've been doing, though. Just like. Okay, don't whine at me. Don't whine. Okay, I would like you to do questions. I think I said 5 and 6 on the front to yesterday. 5 and 6. Do. Don't cross them out, but don't do them right now. Circle 5 and 6. Okay? And then here's what I want you to do. Look at the next open section. Pages 64 and 65. Okay. No, don't whine. I want you to look at 9 through 15 and do exactly what we did. No solving. No solving. You do not have to solve any of them. You read, you tell me what your x and y variables are, and you tell me whether you have a slope and a point or 2 points. That is it. Okay? Now, also notice, what time is it right now? Okay, we've got 30 minutes in class. You have 2 options. Do your test corrections or do your homework, or as yesterday's class shows, some of them did both in that amount of time. It will not take you long. Okay?